Hey mathematicians, we are continuing with our 9.2 quadratics modeling lesson. Today what we're going to talk about is we're going to talk about different ways of writing quadratics, and the main purpose here is for us to be able to have some nice, cool, good shortcuts, in order, like, if a quadratic is presented in a certain way, as in like this way down here, we can quickly find pieces of information without having to use our calculator. It also is helpful, B, to help us write equations of quadratics. So to be able to like take points, and specific points would be good to use for certain forms. And so we're going to talk about all the different ways that you can write quadratics, the specific type of information that it can tell you, and then how it's helpful. We're going to go through this as kind of like this is a nice way, a good way to be able to do this. And I'm going to end it all with, and you also at the end of the day have your calculator, and your calculator can figure out a lot of this for you anyway. But these are just some good things that'll help you get quicker with quadratics, and kind of understand behaviors a little bit. So we have three different forms for a quadratic equation, the way that we can write them. First is the general form, which we've been talking about a lot so far already. Your general form is your y equals ax squared plus bx plus c. Most of your equations are given this way, and it's typically the way that we use to make a system of equations. So most EQs given this way, and system of EQs. This is going to be the form that you use in order to create systems of equations in order to solve for your parameters, A, B, and C, which is what we've been talking about a lot so far. Your other form is called the vertex form. Now, your vertex form looks like y equals ax minus h squared plus k. And the reason why it's called your vertex form is, hopefully you guessed it, because it gives you the vertex. Your vertex in this situation would be h comma k. H is for horizontal distance or horizontal transformation. K is for vertical transformation, maybe. Notice that h here is subtracted, right? So if it's like x minus 3, the x value, the h value here, the x value of your vertex would be positive 3, even though it says minus here. So that's a key piece of information to know, that if you're talking about the vertex, the x value is the flipped sign of that. So it tells us where the vertex is, which is really actually telling us what the transformations are. So remember, all the way back to 8th grade, when you talked a lot about transformations, maybe a little bit in 10th grade as well, this form tells you this is how it's been transformed. It's been moved this many units to the left, this many units up and down, and stretched. Your A tells you how much it's been stretched. It also helps you find your axis of symmetry and transformations. The last form that we're going to talk about is your factored form, and it's y equals a times x minus x1 times x minus x2, where your x-intercepts, so this is the purpose of your factored form. Is your factored form, remember all the way back to 9th grade, your factored form tells you your x-intercepts. It tells you where it's crossing the x-axis. Realize that your x-intercepts are going to be positive x1, 0 and positive x2, 0, right? So the flipped sign of whatever is going on there. So it tells us the x-intercepts. This is this guy right here, this form is the one that I see the most on tests where I'm like, oh, that's really easy to answer this question. Like, what are the x-intercepts? And it's already in factored form, like you'll see an example for. This is probably the most easily missed shortcut question that I see. And so a lot of students will like plot it on their calculator and then solve for x-intercepts that way, when it's just right there in the problem. And that's okay. We can always work a little bit harder or work a little bit longer for a certain problem. But when it comes to the end of the day, if you can have some ways to remember, if you can remember ways to save time on a test, it's going to be helpful. So it says just first plot the graph on the calculator. So it says plot, it doesn't say sketch. Sketch would mean you would have to draw it yourself. Plot just means put it on the calculator. So that's something important to keep in mind when we're talking about vocabulary on your IB exam. I'm going to go to standard zoom. Maybe not. Zoom out. Whoa, weird. Menu zoom. I'll do fit and see what happens. All right. It's a weird looking graph. So the zoom is acting all weird, but that's pretty much what it looks like. It says find the x-intercepts. We don't even have to look at the graph in order to find the x-intercepts because it's going to be the opposite sign of this guy. So your first one is 5, 0. And we're going to have another x-intercept that you can tell from this guy. And I would like for you to tell me what that x-intercept is. Because it's a positive 3 here, your x-intercept is going to be negative 3, 0. You could always double check that by tracing or by doing the x-intercepts. But here we've clicked onto the 0, 5, 0. And negative 3, 0. Then it says find the equation of the axis of symmetry, which, yes, we can use our calculator to double check this. However, also remember that your axis of symmetry is halfway between your x-intercepts. So you can find it without using your calculator. Go ahead and find me the equation of the axis of symmetry. So remember that the equation means it needs to be x equals, right? You can't just give me the number. So it needs to be x equals, and then it's just the average between those two values. Since they have the same y value, they're the x-intercept, y value is 0, we just average those two x values. So this is your x1 plus x2 divided by 2 that we talked about, which is just a formula for finding the average. 5 minus 3 over 2, which is 2. So x equals 2 is the equation of your axis of symmetry. No, that's totally wrong. X equals 1. Sorry. There we go. Yeah, 5 minus 3 is 2. Then divided by 2 is 1. All right. Then it says to find the coordinates of the vertex. So we can check that this was our axis of symmetry by tracing over and double checking that, in fact, our minimum is at 1, which it is. Who knows what our y value is, but that is okay because we still need to find it. So all we need to do from here is just then plug in the 1 in for x, right? If we want to find the coordinates of the vertex, we already have the x value of the vertex. The axis of symmetry goes through the vertex and it tells you the x value there. Now we just need to know what is the y value when x equals 1. So we plug it in for f of 1. All right, go ahead and tell me what the y value is for f of 1. 1 minus 5 ends up being negative 4 times 4 is negative 16 times positive 4 is negative 64. So the total coordinates then end up being 1, negative 64. So this whole thing, if we go through this problem, you could use the graph absolutely to find all of these things. But if you know how to find these right away, because of the form that the quadratic is in, it's very easy to pull these out and have this be an incredibly quick problem. And so when your IB points start to be broken down, and it's like, hey, this is a 1-point problem. It's because they're like, this should only take you a minute because it's already in factored form. So your IB test will also be like, this should be quick, guys, and we'll test you on that. All right. Another reason why we care about the form is when we are graphing. So in order to sketch that graph, we're going to refresh a little bit on what it means to factor. If you remember how to factor, awesome. It's going to be helpful when you're coming across plotting things like this. So we're going to have a little bit of a refresher on how to graph or how to factor. So if we have negative 2x squared plus 8x plus 24, I'm going to take out my greatest common factor first, which is negative 2. And I'm going to think of two numbers that multiply to negative 12. I make a little x symbol, multiply to negative 12, and add to negative 4. And that ends up being negative 6 and positive 2. They multiply to negative 12, and they add to negative 4. So it becomes x minus 6 times x plus 2. If you're struggling with factoring but would like to be able to be quick at it again in order to help you with this unit, there will be stuff on your additional help links in order to help you with factoring. But now that we have this as our factored form, we know a lot more information about this parabola that we can sketch. So it says we want the x-intercepts as well as the y-intercepts. Your x-intercepts are told nicely to you in this factored form. Your y-intercept, remember, is when x is 0, and it's pretty easy to spot from here. If you remember back from our 9.1 lesson, it was really easy to spot. So go ahead and see if you can tell me what your y-intercept is. Remember that C is your y-intercept, right? So 24 is your y-intercept. So your y-intercept is 0, 24. And we also want to know the maximum or minimum point. So we'll just call it vertex for right now. Well, the x value of your vertex is halfway between your two x-intercepts, right? So 6 minus 2 is 4, divided by 2 is 2. And then if you quickly plug in 2 in for this, 2 minus 6 is negative 4, times negative 2 is negative 8. Negative 8 times 2 plus 2 is 4. That's a negative 32 all multiplied together. And then you've boom, 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 found all of these pieces of information really quickly, and you don't even need to use your calculator or take time to piece it all out in order to do this problem. We want to sketch the graph. So remember that with sketching the graph, we need to do which of the following with our graphs. When we are sketching a graph, we are making sure that we label our axes, right? So you need to label this X and Y. That is 1 point when you graph things on your test. You also need to scale 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go up by units of 5. And it needs to be consistent. You cannot change the scale of your graph. If you do, that is incorrect. Then you also need to, when you plot things like your intercepts, negative 2, 0, 6, 0, you need to label those points, especially because it also says clearly label those. And then our y-intercept is at 24. And then our vertex is at 2, positive 32. Sorry. Oh, hopefully you guys caught this. 2 minus 6 was negative 4 times negative 2 is positive 8. So that would be 4 and positive 8, making it positive 32. And that wouldn't make sense, right? With a parabola, you would think that it would go up and down like this. So having a negative 32 would not make sense for what we understand a parabola to be. So always make sure that you're thinking because you can catch silly mistakes. 232 is our vertex. And then the last thing, labeling all of your intercepts, labeling your vertex, the last thing that we need to do is just draw something that looks like a parabola, right? Drawing a curve. Yes, you could just get a point for drawing anything that looks like a parabola sometimes. Not all problems, but sometimes. So just making sure that you make it shaped curved because it's supposed to be. All right, hopefully you got all of those things. Labeling your axes, scaling your axes, labeling your intercepts, labeling your vertex, and drawing the appropriate shape. So all of those are super important when you are graphing on IB exams.